I bought this test board for a project I had in mind for work, but actually I quite like it, and I've got a better idea that I want to put it to use for. But it's not been easy actually to get this underway, this project I've got in mind. So I thought I'd share with you some of the difficulties I've had and how to get around them. So if you decide to buy one, then hopefully your navigation path around it will be much quicker than mine. All right, let's have a look. Okay, here's the device. It's basically an Elecrow, I think that's how you pronounce it, E-L-E-C-R-O-W, ESP32 display, 3.5 inch display, HMI touchscreen. So there it is, and on the back it's built really well. So you've got your ESP32 device there, which of course gives you Bluetooth and Wi-Fi and all that good stuff. And you've got a boot and reset button, a USB-C for either powering or uploading your sketches, your programs. You can connect an external battery here. You could actually connect an external speaker. This apparently will drive a speaker directly. I'm yet to try that. And then on the breakout, you've got one UART serial port and I2C port, and they give you a couple of GPIOs, which is kind of disappointing. I thought they could provide more than just 2 IOs, because of course that's what you want to do with a microcontroller, is control stuff. So just having 2, you're fairly limited, but in any case, you've got I2C and a serial port, so you can probably expand out from there with another device. Just have a look at the spec. So I've bought this 3.5 inch one. Not sure you can see that very well. See that 3.5 inch one, which has a resolution of 320 by 480. It's a resistive touchscreen. They do actually give you a little stylus in the box, which is there. You can use your finger, but of course you get fingerprints all over it, as I have done, but yeah, that's fine. You also get USB-C lead in the box and a connector for one of these here. You don't get more than just the one though, so that's probably the first problem I hit, is working out what connector types these are, and I think managed to solve that, and I'll more on that later on. But yeah, you also want something for your power and your speaker connector if you're going to utilise those. So you're going to have to find the connectors. And just carrying on, so it is resistive touchscreen. It's ESP32, 240 megahertz processor, 4 megabytes of flash, 520k of SRAM, 448k of ROM. It's the display driver is the ILL9488, which differs from the others, but that's no problem. It works absolutely fine, and the driver libraries for it support that perfectly. Screen type is TFT. It's got a speaker jack, SD card slot. Color depth is 262k, and that's the active area there in millimeters, 48.96 by 73.44. All right, brilliant. It's really well built. I like it. Solid. Got mounting holes there, so I'm sure you could quite easily put that into another enclosure, tidy it up even more. But let's just go through the various challenges I face, because I've never used a screen like this before, and the driver libraries to drive it, and it's quite difficult to find any decent documentation really on some of this stuff. So let me just go through how I've got around it all. Okay, the project I got in mind is to replace this with that board, because look at it, it's a couple of years ago it started doing this horrible flickering thing, and yeah, it really annoys me, so I want to replace it. And from the board I'm going to run a cable under the desk along here into my cupboard where I have my computer stored basically, and also there's a couple of fans here, and they have stopped on occasions. So for that reason, that's why I put this together. Not only have I got a clock, but it's also my temperature sensor, which is going to be in my PC cupboard. It's going to be wired back to this and displayed on here like you can see. And it can then alert me when it considers the temperature is getting too hot. But let's have a look at it running. Okay, here it is running. Unfortunately, the camera doesn't pick it up very well. In reality, it looks absolutely stunning. It's absolutely sharp image. The colours are very vivid. This is green, bright red, etc, etc. There's my temperature gauge here, and I've got a potentiometer wired up to it at the moment, so I can simulate any kind of temperature range. If I take it up into the medium, that actually changes the clock to amber colour. If I take it up into the red, then obviously the clock goes red as well. And if I come out of that, it goes into green, although it doesn't look green on the camera, unfortunately. And then in addition to that, got the date formatted, some nice text, and then I've added my YouTube channel stats. So down here I've got number of views, down here I've got number of videos, and this is number of subscribers. So the magic number for me, if you know anything about YouTube, is I need to get to 1,000, okay? So if you find a channel of use, please click the subscribe button and help me get this increased up to 1,000 very shortly. So the first step when I got the board was to go to the manufacturer's website. This is it, elecrow.com. Then you can find the board. So you go to brand, you go to the HMI display screens, and then you've got each option here, the 2.8, 3.5, 4.3. I bought the 3.5 ESP32 version. If you click on learn more, then I thought, brilliant, there's all these lessons here that I could work through and get an understanding of how to drive this thing. But they use this thing called LVGL GUI development tool, and I found it very difficult to follow, and actually I couldn't get any of these sketches to actually work for me. So I went onto YouTube, because it's a great source of loads of information. Some great people have put lots of information on YouTube for sharing. And when you do a search here for TFT ESPI, as I did, then you'll find that loads of people have shared information on that library. So I went through that, found the library. You can get it on GitHub. I'll put a link in my description below. But it's here. It's on GitHub by a guy called Bodmer. It's all free. Download it. It's absolutely brilliant, and you can download lots of examples from YouTube, and you can just work out how to use it from there. So in my code, you can see here I've included the library there. Look, TFT ESPI. Okay, if you go into your examples in your IDE, so if I go to examples, then down to TFT ESPI, you've got loads of sections of examples. But if you go into 430 by 320, that's the resolution of the 3.5-inch screen. You've got all these examples you can open up. I actually used one of these on my board with the gauge for the temperature. I just took that example, stripped out all the stuff I didn't require, and used that. I think I even in my notes make a comment about where it's extracted from. There we go, extracted from Arc Beta Demo. Okay, so that's tip number one, use TFT ESPI. Yeah, just on TFT ESPI, actually you don't even need to go to GitHub, I found. If you just click on your library tool there, and then in your library manager, the search box at the top, if you key in TFT_ESPI, I found that it came straight up. There it is there. I know I have installed it, but if you haven't, then you'll have an install button there. Click it, it will do it for you. Okay, nice and simple. So having installed that TFT ESPI, and I started to get underway with that, I've realised that there's quite a large header file that you have to go through and edit. When you go into your library folder and you select the TFT ESPI subfolder from there, there is this header file called usersetup.h. Now I've actually replaced that header file with the appropriate one for this particular board. But if you look at the original one, if I go back to the GitHub page here, and scroll down. You wouldn't do this normally, but because it would install it when you'd go through your library manager for you. But you'd go to this user setup.h. If you go through this, you have to know every one of these parameters and edit this file with the correct pin number, fonts, all kinds of stuff that you have to go off and research. So again, on YouTube, I had a look on there, and Ralph Bacon actually has done it all for us. Thank you, Ralph. So I'm going to share his GitHub page on here, where you can download the header file with it all set for you. So if I go into my header file, which is, sorry, let's just open that folder again. If I open this one, and I'll open that in Notepad++. There you go, it's done here. So you can see this is much shorter. He's cropped all of the rubbish out that you don't need, but all of this setting is important to get you up and running with that particular 3.5-inch Elecrow TFT model display. Okay, so that'll get you up and running straight away with TFT ESPI on that board. Okay, next up, this is a small one really, but it did hold me up for a while. By the way, I'm using Arduino IDE. You might be using something else, I don't know, but I'm using Arduino IDE. But what you would do is get your sketch ready, and then you would click the compile and upload button, which is there. Okay, but it didn't actually upload, it kept failing. So then I tried pressing the boot button, I tried pressing the reset button. So on the video down here, the boot button is here on the left and the reset button is there on the right. It is labelled just above them, but you can't read that on the camera. What you have to do is compile your sketch first. If I click that, it will compile first, and it's going down in the bottom right hand corner. And just wait for that to finish. Okay, so it's finished compiling. You have to press and hold the boot button, press the reset and release, then let go of the boot button. Then it starts uploading. Okay, let that upload. 40, 50, 60, 70, 80, 90, 100%. And then it will just sit there. So it doesn't actually hard reset it over the wire. So you also have to press reset. Okay, there you go, now it's running. All right, that's tip number 3. Okay, next issue I had was I wanted to put a JPEG file and show it on the display, and for the JPEG file I was going to use the SD card reader, which comes with the unit. If like me you've only got fairly new SD cards, which are sort of more than, I don't know what it is, 16 gig I think is the limit. This only supports FAT16 and FAT32, but you can't actually format these under your normal Windows operating system to FAT32. So there is a way around that, which I've done with this one. If you go to this website, I will put the link down below, but it's this website here. Kind of comes to a quirky layout really, and it's hard to find where you download this utility. You actually have to click on this image here. So if I click on that, you can see it's now downloaded it. If I open that, here we go. That's it there. You don't actually have to go through an install. It runs immediately. And I'll just bring it over, it's gone on my other screen. There you go. It'll allow you to select which drive, and it will format it to FAT32. Be very careful which drive you're selecting. Make sure you got the right one, of course, and you don't go and format your hard drive or something silly. So be very careful with that, but it solves the problem. It will format any size SD card, as far as I know, to FAT32 format. Okay. Okay, next issue I had on that JPEG image. This is my JPEG image here. It's not a very good photo, I know. But I wanted this to show, sort of alert me that the NTP clock hasn't synced yet. It's still trying to synchronize to the internet time source. So I did this little image of me cut out using GIMP, and it took me forever to work out what was going wrong. It just wouldn't display it. It rejected the video, the JPEG file basically, and that's because the decoder only supported 24-bit color depth, and unfortunately GIMP doesn't allow you to saving 24-bit color depth, or at least I couldn't work out how to do it. So luckily I found this useful website over here. So again, I'll leave a link to this in the description below, but you just drop your image file here, okay? Then you need to adjust these settings. So let me just turn off my video camera for a second. There you go, you can see it all. So you set this to 24-bit, you must set this to you set this to JPEG, you must set this to 24-bit color depth, and I use this YCBCR. Quality, it's up to you. I think I used 85 because it was the default. Compression, you must change to progressive, and leave these as they are. So I don't know what all these are. So interleaved, optimize Huffman codes, blah 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 blah. Then you click convert file, and it will convert it. Then you can click download, copy that to your SD card, and it should all work. Okay. Okay, next tip, you can see in my code I've got these sprites. All right, so the sprites are a mechanism for displaying a graphic on your display, and you can quite freely move it around. And these reference further down somewhere, so it's creating the sprites, then we have to push an image into that sprite. This is the image that it's looking for. That name there, so it's got PKAE Electronics logo. So on my unit here, the PKAE Electronics logo is that there. That's my YouTube logo. Then I've got subscribers there. So that is that logo there, where my number of subscribers is shown. Then I've got an updating sprite. When this turns to a green background rather than red, that means that it's going off through the API calls to update this, so it's indicating it's in an update phase, okay? So in order to define these logos somehow, rather than store them on the SD card, I did it this way. If I go to my header file logo.h, this is where they're defined. So you can see, got all of the RGB pixel data for every single pixel of my subscribers icon. Scroll right up here. My electronics icon and so on. So that looks rather daunting. It doesn't actually take a huge amount of space in the scheme of things, but in order to do that, you don't have to work this out yourself. There's this handy website called Rinky Dink Electronics. So all you do is you go into the website. Again, I'll leave the link. You click choose file, go off and find the graphic that you want. So let me pick, say, this one, and open that. It's now got the file. You'd select .c, click make file. It's now ready for download. Click that. If I click keep and I open this, let's go to the folder and I'll open it in Notepad++. There you go. That's it. All you got to do is rename that to a .h and include it, or paste it into your header file. It creates the name for you. That's derived from the file name that you pointed it to. It can be a PNG, it could be a JPEG, whatever. And there's all the data all done for you. Okay. Right. Next is these connectors on the board. So they're mounted on the back here, and you only get one lead in the kit. So that's not really enough if you intend to use all three of these, or if you wanted to use the speaker or the power connector. Well, that's a 2-pin connector, not the 4-pin that's provided. So I had a good look around and I did struggle for a bit, so I expect others will be struggling to find that. If you look on this eBay screen here, I did find this, and I'm pretty certain it's the correct ones, but until it arrives, and it's not going to be arriving now till the new year, so that's a couple of weeks away, and I've ordered it anyway. If you want to try it, it's £2.77, but I will confirm once they've arrived and tried it out. And lastly, if you want to display your own YouTube channel statistics like I've done here, there's a library for it, which I have utilised. It is this one here, YouTube API.h. So if you go to your library manager and again type YouTube API, sorry, mistyped, API, then it will come up and you'll have an install button there. If not, you can go to your GitHub page. I will leave a link in the description below. And in order to use it, there are some descriptions down here, but you need to set up an API through Google, and you need to get your details, getting Google API key, and you need to get the exact YouTube address from your YouTube channel. Okay, go to YouTube and do a search on it. There's loads of people done guidance videos on how to use it. I won't cover it all off in here. So that's tip number 7. Right, just to add on that YouTube API library, the quickest way to understand how to use it is to go to the example, of course. So if you go to example, find your YouTube libraries here. I picked ESP32, so that's what we're using. Then it's got here channel statistics, so that will open up a demo sketch, and then you can copy and paste that into your sketch. Okay, however, you may find, I think you probably will, that it fails to connect. When you look at the serial monitor in this, you'll get an error message that it's failing to connect to the API, and you have to add this little line here, which took me ages to find out through loads of Googling. So you have to put client.setInsecure, okay? Lowercase set, uppercase I, and then insecure, the rest of it's lowercase, as you can see there. Then it worked fine. All right, that's tip number 7B and my final one. In summary then, this I think is a great little board. I really like it, really well built. It's got all the features you need. Bit disappointing they've only given you 2 GPIOs, but I have to accept that, I guess, and work with it. So you do have the UART on the I2C. If you like the video, please click like and subscribe. Help me get this number up to 1,000, please. It does help. And if you want to purchase one of these boards, click in the link in the description below. It's an affiliate link. It doesn't cost you a penny more, but it helps me to part fund this channel to be buying products like this out my own pocket. Okay, so I hope you enjoyed it.